Section 6.6, we're going to be working on transformations and similarity. A couple more vocabulary words. A dilation preserves angle measures, but the lengths are proportional. Preserves angle measures, lengths are proportional. That should be a review vocabulary. But the two different kinds of dilation, enlargement or reduction, exactly what they say is what they mean, is reduction. If we have a picture like this, dilation of an enlargement would be from A to B, because obviously A would have to enlarge to B. Reduction if you went from B to A. So the one word dilation, but the two ways to describe it could be enlargement or reduction. Notice the angle measures are the same, exact same, congruent, congruent, congruent over here, but the sides are only proportional. I don't know, maybe it's about twice as big. Scale factor, a little bit different than dilation. A scale factor, again, a review vocabulary word, the ratio of lengths of the corresponding sides. So if you're relating the corresponding sides, the 12, you would pick 12 to 6. Reduce it down, it's a scale factor of 2 to 1. 8 to 4 would reduce to 2 to 1. 6 to 3 would all reduce to 2 to 1. If they asked for it the other way, you would have to say it goes from 1 to 2. Then B to A, you would know it started at B and went up to A. Dilations on a coordinate plane. We can describe a dilation with this notation. Don't let this notation freak you out. It's not super complicated. We basically have a point, x, y. We multiply both the x and the y by the same number. In this case, we call it k. K is the scale factor that we're multiplying it by. So if you multiply x by 3, you have to also multiply y by 3. They have to enlarge or reduce at the same rate. So if k is bigger than 1, if you're going to multiply by something bigger than 1, the dilation is an enlargement. That should kind of work for you like just common sense. If you have twice as much as somebody else, it's going to be bigger or it's going to be more. If that number k is between 0 and 1, you can't just say less than 1 because you can't have a negative number. You can't multiply a coordinate by a negative. So if it's any fraction or decimal between 0 and 1, 0.5, 3/4, 1/2, same as 0.5, 0.2, any of those numbers, as long as it's less than 1, the dilation is a reduction. So how does that look? Here's a coordinate plane. Hopefully you have this on a handout so that you can draw it, otherwise you're going to have to draw your own graph. Draw a dilation of quadrilateral ABCD with a scale factor of 2. So we're going to take every x and y and we're going to multiply them by 2 so that they get twice as big. Well, if you look at point A right now, point A is at over 2 up 1. Or it's supposed to be. It looks like it's off just a little bit. Multiply that by 2, your new A, we're going to call it A prime, A with a little, what is that called, apostrophe up there. Multiply that by 2, our new A is over 4 up 2. So you don't just make it taller, you change both the x and the y. So over 1, 2, 3, 4, up 1, 2. There's our new A prime. B originally is 1, 2, 3, 4, and up 1, which means our new B prime, multiplying both by 2, is going to be over 8 up 2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. C was at over 1, 2, 3, 4, down 1. Therefore, our new C prime, is at over 8, down 2. Over 8, down 2. And our old D, original D, was over 1, down 1. And our new D prime, multiply them both by 2, over 2 down 2. So your new diagram, if you connect it, it got twice as big, but you don't draw it in the exact same spot because the dilation doubled both the x value and the y value, so it moved over and up. It expanded both directions. And that would be tough to do, to know where you put the a and the a prime compared to each other if you didn't multiply over the coordinates. Who knew that this point, if you multiply it by 2, ends up over there? Do the coordinates, multiply them out so that you know what the new coordinates are. Let's try this one. Draw a dilation of triangle ABC using a scale factor of 1/2. So because this number is less than 1, it's going to be a reduction. You know your triangle is going to get smaller. We'll do the same process. A was at, here's my origin over here, 1, 2, 3, 4, 1, 2, 3, 4. Over 4, down 4. That's comma. B was over 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. And C must have been over 8 as well, but now it's down 1, 2, 3, 4. Where do the new points end up then? We've got A prime. You have to cut both of these in half, so it's at 2, -2. B prime will be at 4 and 1. Cut both of those in half. C prime, 4 and -2. See how nice it was that I gave you all even numbers so that when you cut it in half, you still have whole numbers? So draw the new triangle. Over 2, down 2 is your A prime. B goes over 4, 1, 2, 3, 4, up 1, B prime. C over 4, down 2, there's your C prime. Take a look at that triangle. It's definitely, well, if I draw it straight, it's definitely proportionate or similar to the big triangle, but look at where it moved. And maybe you don't, I don't know that you would know that if you reduce this by a scale factor of 1/2, that's where it ends up. Got to do the coordinates. Okay, other way around, what is the scale factor of the dilation from A to B? What is the scale factor of the dilation from A to B? It definitely got bigger, so we know that our number is going to be bigger than 1, but on A, our first point is over 1, up 1. Well, not on B, let's do all 3 points of A first. Over 1, up 1, this one went over 1, 2, 3, up 0, and the third point went over 2, up 1, 2, 3. On B, we went over 1, 2, 3, up 1, 2, 3, and you can probably see already what our scale factor is going to be. Over 1, 2, 3, 4, 5, 6, up 1, 2, 3, oh, we should do this one first. 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then our last one over 6, up 1, 2, 3, 4, 5, 6, 8, 9. Every coordinate got multiplied by 3. So the scale factor is 3. What's the scale factor of the dilation from B to A? Then that would be 1/3. You reduced it from B down to A 1/3. If you want to, you could say K equals, because that was our formula up here, where K is the scale factor. But that's it. That's what you're working on in section 6.6. Draw it out, mark it down. Shouldn't be that difficult. Good luck.